All right. Another exciting day in the life of Chico and its environs. So, when I was kind of finishing, when I tried compiling, I created an error, and when I asked about the error, I got a lot of blank. Well, I didn't get any answers, so that was either disinterest or not being sure. I'm going to err on the side of not being sure and talk a little bit about the compiling process. If you're in my 511 class, I know what WIS is, then you get it twice. What are the 4 steps of the compiling process? We'll call them steps 1 through 4. What's part of compiling? Name anything that you think is part of compiling. Yeah, you don't even have to raise your hand, just shout it out. Linking. Linker. What else? Say that again? Yes, but now you're being more detailed than I need. So if you're in, I don't know, I'm looking for like 311 level, right? At 311 you weren't introduced to the term scanning yet. What else happens when you compile? It isn't G++ and then the linker runs. What else happens? Huh? Yeah, I mean, certainly the parsing happens, but parsing is part of what? It creates an executable, so that's the linker's job. The linker the output of the linker will generally be a machine readable executable. So what happens before linking? I'll give you another one. It isn't a trick question. Some of these are easier than you're afraid to. Compiling happens. In fact, I would say compiling, we'll put compiling right there. What happens before you compile? Or what happens after you compile? Thank you. Someone else may have said it, but I didn't quite catch it. Saying it under your breath so that if it's wrong, you can't be accused of being wrong. There's some. All right, that's 3 of 4. I'm looking for one more. It's actually something that happens before the compiler. Preprocessor, thank you. All right. So, in broad strokes, these are the 4 steps that happen. When you begin, let me go to my handy dandy pen here. So when you start, you start with a CPP file. That's going into the preprocessor. How do I do this? And the question is, what comes out of the preprocessor? Let me get to that in a roundabout way. Let's write a little preprocessor stuff. I'm going to do this in C. Let me see what I want to call this. I'm going to call this add5.c because at some point I'm going to be adding 5. Let me actually start with the header. And let me, since I have a fair amount of real estate, So that is this is add5.h. Let me actually do this, just so that that's not ambiguous. Let me bring up add5.c. All right. So whenever you type G++, it runs through all 4 of these steps, right? And the 111 students are already doing that, so there's nothing new there. What is perhaps not as realized is that there is an option to suppress subsequent steps. So, for instance, I can provide an option, an uppercase E, and that means suppress everything after the preprocessor. All right. I'm going to throw this out, a P option. This one doesn't have anything to do with suppressing. What it does is it hides some additional junk that gets spit out, and just so it's easier on our eyes, I'm throwing in the -P, but you can kind of smoke and mirrors, ignore the -P, right? It's the -E that's actually causing the G++ processor, G++ compiler to stop after the preprocessing. So I can say, let me go ahead, I'll quit out both of these. I can say G++, oh actually I'm going to use C. All the concepts are the same. G++ just adds a bit more crap that I don't want to have to sift through. And again that. Okay. So what the preprocessor does is, if the preprocessor doesn't recognize it, it literally just spits it to standard out. Preprocessor doesn't have the slightest idea, spits this to standard out. What the preprocessor understands is anything that begins with a pound sign. So this is, we always just look at this and say, oh yeah, include add5.h. We wanted to use terminology for it, we'd call this a preprocessor directive. And so the directive's pretty primitive. That's all it does. It literally takes a copy of add5.h and it puts it at that location. In fact, if I put that there several times and I run this through the preprocessor, it follows that directive several times, right? So the output of the preprocessor is more C++ code, or it's your same C++ code, except that once you have all your pound include statements and so forth, rather than it being in 20 different files, it's one huge stream of output to standard out. And that big stream of output is what the compiler gets. So it goes into the compiler. And you can use the -S option to suppress everything after the compiler. Okay. Now this is not C++ code, so if I try compiling that, now we get errors. Okay. So let me actually back up, go back to the preprocessor here. Let me just run that to make sure that that's the command I've been doing. How can I generate an error in the preprocessor? Give me something to type on my keyboard that will cause the preprocessor to vomit. Remove the .h from add5. All right, so that's a preprocessor error because the preprocessor couldn't find that file. Another thing, another option is oh, I don't know. Come on. Now it's entirely possible that there's a circles and rectangles preprocessor directive, but probably not. I actually haven't tested this before. If it's in there, then all right. So those two errors we saw with the file not found and with this error here, those are being generated by the preprocessor, right? The C++ compiler hasn't even been invoked yet. So now let's write a little valid C++ code here. Oops, I got that open here. You know, maybe what I'll do is I'll leave that for the sake of posting to the course shell. So I'm going to change how I was thinking I was going to do this. I'm going to move add 5 to rhyme, and I'll move add 5.h to rhyme.h. And I'm going to remove that. That was failed. First.l is what I wanted to talk about with regards to flex today. So we'll see that later in the class. It doesn't have anything to do with what we're doing right now. All right, I have those two. I want to start add 5.c. Let me see. Add 5, we'll take an integer x, and then we'll say integer y is equal to x plus 5, and then we'll return y. And then we can say integer age equals 10. In fact, I don't even need to, let me leave that out. I'm not going to have any input or output on this. Age is equal to add 5 to age. So that'll effectively make age 15 by the time we hit line 11, right? All right. So coming back here, I'm going to make it through the preprocessor. I actually don't have any preprocessing directives here, so exactly as we see it here, that's what the compiler is going to get. We'll do the -s, and we should see some assembly language. So let me go like this. Yes, thank you. Force of habit. All right. So what the compiler generates is something with a .s on it. So this would be assembly language. We can look at that. I can look for add 5. Okay. I can also look down further here. Here's main. You don't even have to understand assembly language to kind of parse this if you understand programming generally. Here's the main function. Here's where add 5 is called inside of main. Yeah? What if I want to do everything except the assembler? And if there's any option that you definitely know, it is the option that suppresses the linker so that it doesn't run. Every one of you knows it. Some of you just don't realize you know it. when it's done assembling, what kind of thing do I have? General. A .o file, which is machine readable code essentially, yeah? So a .o file, how do we create a .o when we use G++? Dash C, lowercase c. So there's add 5.0. If I say file, add 5.0. Okay. Versus file add 5.s, assembler source. Right. And then finally, if we want to do all the steps, we don't provide any option, and this will ultimately create an effect. Let's do this. And it's named A.out for historical reasons. Anyone know what the A represents in that name? Why do they call it A.out and not B.out or C.out or whatever other weird thing they would have called it at Bell Labs? Huh? Assembler. Assembler output. So that's where that name came from. Is it's a little bit of a lie because we have a linking process in there, but so be it. So let me look at my add5.c, and let me move the source code. Actually, before I do that, what's the difference between line 2 and lines 5 through 9? What is line 2 and what are lines 5 through 9? Right, I would call this the function declaration or function prototype. And this would be the function definition. Let me go ahead and, all right, that works fine. So the question is, well, why would I need this information here? And the rule of the compiler, it's certainly that way in C, but it becomes even more strict about it in C++, is before you can use it, you have to tell the compiler what it is. So this is telling the compiler that I have a function called add5. It's not necessary though, because here, by default of showing the definition, we're actually showing that we have an add5 function. We're showing that we have an add5 function that returns an integer and accepts an integer as an input parameter. Yeah. What if I do this? I'm tired of typing. We'll stop there. Is that an error? Let's give it a try. No, it's in, no, let me do this. All right. So that's not an error. So let me repeat what the purpose of the function declaration or the function prototype is. It is to let the compiler know what it is before we should use it, or before we use it. We're not under any obligation to use it. All this is saying is, hey compiler, if I should use the add7 function, make sure that I'm only giving it one input parameter and that it's an integer, and make sure that it's returning an integer. Yes? but I'm not under any obligation to use it. So that's one thing to note. The second thing to note is this is not increasing the size of your executable. It's information for this compiler to help you use things correctly. So I can go ahead and I can list these all day long, and all that memory, you're providing a ton of information for the compiler, but you're not using any of it. So when the compiler dies, when this process, this part of the workflow ends, all of that memory, if you will, all of that learned information is gone. It's just for the compiler to help you use things correctly. And that's part of the definition of the language. Before you can use it, you have to let the language, or I'll use the term compiler, you have to let the compiler know what it is. Different languages may have different languages have different standardization, but that's the way it is in C and C++. So you're doing that quite a bit. You're doing a lot of that immediately in 1.11 and not realizing it. If I do, again, I want to do this, just go through the preprocessor. So let me just do that so we can go to -e-p, and what I'm going to do is I'm going to pipe this into WC word count, and I'm doing the -L option to get number of lines, just so you can see that. There it is. There's 16, so after it runs through the preprocessor, there's 16 lines that need to be processed by the compiler. If I go into add 5 now, and I say #include IO stream, let's see, I'm going to change to C++. Let me go back so that you know that I'm not lying to you. Let me leave it like that. Let me come zoom in here. Let me change this to G++. All right, 16 lines, right? Now I come back here, I add #include IO stream. I'll do it again. 12,000 lines. So IO stream's quite large. Now, one of the mistakes in terminology is, particularly in the 1.11, 2.11, and maybe in 3.11, is people say, oh, you have to include the library. No, you're not including a library. You're just including C++ code. I'll tell you what a library is in a minute. It's actually a thing, and it's not that. I'm including a header file. I'm including IO stream. I'm not including a library. What is the purpose of me including IO stream using terminology? Why do we have add 5, add 6, add 7? How does that serve us well? What is it doing? Why do we have function prototypes? We have the function prototypes because it lets you use it. It provides information for the compiler should you decide to use it. What is IO stream doing? Use the same phrasing. It is providing information to the compiler about functions and objects, frankly, C in and C out, right? Providing all the information about the functionality of C in and C out should you decide to use it. Now, in any simple program, you're likely using just a minuscule part of the possible things that you could be using C in and C out and O streams and I streams generally, okay? But that's all it is. That's all that's happening when you're #including IO stream, is to provide information for the compiler that does not add to the size of the executable. It's just a whole bunch of information to make sure that, to help you use input and output correctly in the language. All right? So we'll get back to this in a little bit. The question is, I started this by writing this code without the function prototype. If we rewind a few minutes, basically my code was this right here, and I didn't have any function declaration or function prototype, and it worked just fine. So it raises the question, well, what use are these prototypes? since I didn't need it in this case. And the utility of it is I'm going to take line 9 through 14 here, and I'm going to write it out to a function, to a file called usefulfuncs.c. And now I'm going to get rid of that. Let me comment all these out. I don't need that anymore. So here, on line 11, we're using add5. And just let me go back to the CC. Oops, let me bring that up. Let me just emphasize it with the preprocessor that the preprocessor doesn't have a problem with that. It's happy, right? That's all we have in that file. Again, if we go back, see all this other stuff's commented out. So this is all we have here. Next is, it survives the preprocessor fine. Will it survive the compiler fine? And I'll put the -s to make sure it does not do these last two steps. It will only do preprocessing and compiling. Is that a little low? Let me do this. Does that help? -s. All right, there's my command. I don't want to do that. All right, so I'm just running it through the preprocessor and the compiler, not the assembler. And there's my error. Before we can use it, we have to tell the compiler what it is. We never did tell the compiler what add5 is. So that illustrates the use of the prototype. The prototype goes from being optional, if you will, to being mandatory if I start moving source code into different files. Oops, sorry, I'm over here. So let me come up here and uncomment this. There, now I'm telling it what it is before I try to use it on line 11. Let's try, did I write that? Okay, let's try compiling that again. Again, it's not doing the assembling, just the preprocessing and the compiling. And it worked fine. Let's take it one more step. Let's take it through the assembler. Put the -c option. Do not do the linking. That works just fine. Now we have machine-readable code. Let's take it the final step. If I don't put any option, it's going to run all four. We get an error. Given this diagram, what has to be complaining? The linker, right? It did the other three just fine. So it's a linker complaining. This is where my question came from at the end of last time. What is it that's complaining? It's the linker that's complaining. Okay? So a key part of software engineering prowess is to understand where your errors are coming and to understand that four-step pipeline. Is it a preprocessor error? Is it a compiler error, which is what all the 111 students get, right? We're not too worried about the missing semicolons and stuff. For those who went through the full sequence, remember how it was a big thing figuring out the missing semicolon, and now it's like, spend 10 minutes on that and 3 hours on harder problems. So those are the compiler errors. And then you have these linker errors. So undefined reference, why exactly is it saying that add5 is an undefined reference? What is it complaining about? This is the program on the left that I just tried to compile. Doesn't know the actual function. Who knows what add5 is? Does it add 5? I mean, that's just a name. I could have chosen any name. It could do anything at all. And what we compiled, this is all we compiled, it doesn't have any idea what add5 is. So what we have to do is we have to do these same 3 steps, right? It did the first 3 fine with add5. We have to do the same 3 steps on our useful funcs. And let's look at it just to make sure that, okay. So let's do the first 3 steps on that. gcc-c, usefulfuncs.c, and it does it just fine. Now I've got 2 machine readable files here. All I have to do is have the linker link them together into a running executable. That's the name. So I can say, I'll say gcc add 5.0 usefulfuncs.o. What did I do? What did I do wrong? Hang on. Let's see what we got here. What does pound include do? It includes information for this so that this can make sure you use things correctly. It's not meaningful downstream. Let me see. Let's see the error again. In function main, undefined reference to add 5. Let me look at useful func. Let me look at it over here. There's something that I'm not seeing. It's very obvious. And maybe I compiled with G++ by accident, one of these things. That would be my guess. Change that to an O, change that to an O, get rid of that. Yeah, I must have accidentally compiled one of them with G++, so they weren't linking up okay. So there it is. So whenever you have multiple files, then it runs through these first 3 steps on each and every single file. Okay? And keep in mind, you don't have to do them at the same time, and they have no knowledge of each other. I can compile the source to add 5 on Monday, and then on Tuesday I can compile the source to useful funcs, and then on Wednesday I can go ahead and link them together. Yes? Each source file that you have goes through a process that is completely invisible and unknown to every other source file as far as bringing it down to machine runnable code. All right? So whenever keep in mind this 4-step process, if I have 10 files, really it's this 3-step process 10 times, and then this happens once at the end with all 10 machine readable files. Yeah? Getting back to this here, not this other one. So again, we have this so that the compiler can help us use it properly should we use it further down in the file. If I've got a large application with dozens of different source files and all of them need to use add 5, I have to put this prototype in all of those different source files, yes? Before I can use it. That is error prone because I may, it'd be easy for me, I could copy and paste, but it might be possible that I accidentally make one uppercase. And then, depending on how I use it, I either get a compiler error or a linker error. So let me see. If I do this file, let me ask a question. I do the same thing. I compile add5.c, I compile usefulfuncs.c, and then I link them both object files together. If I change that one character on line 2, what am I going to get an error in? The compiler, the preprocessor, the compiler, or the linker? So if it's the linker, these two will work fine and it'll vomit here. If it's the compiler, it'll vomit on this line here. So someone say again what your thought is, which one it'll be. Compiler. Why the compiler? All right. So the compiler's happy with this. This is saying, should I use the add5 function with an uppercase A? Make sure I use it properly. This is what it returns. These are the inputs. Here, I'm calling a function, and the compiler says, I've never seen an add5 function before. You're trying to use it before telling me what it is. I'm gonna complain right there. That's absolutely correct. Yeah, it's giving me a warning. GCC is being a little bit permissive, but that would definitely vomit in C++. Okay, what if I make this uppercase? The linker will get mad. Why will the linker get mad? Let's do them all. Let me make sure I wrote that out. So let's do that. That's fine. Let's do that. That's fine. Now let me. There's the 2. Linker error. Why are we getting a linker error? Right. This one compiles just fine. In fact, let's look at the assembly language code for this right here. So GCC -s, and I want to compile add5. That's going to create add5.s. This is the top of that assembly language file. Here's the main function that I'm diving down into. Here's my call to add5. Let's look at the assembly language to the other one. Let me come over here. Let me look at this. Will be add5.s. Okay, here's the call. Line 17. There's the source. On line 5 of the other file, it's a case-sensitive language. These functions are not the same at all. So the linker tries to link the call with the source, and it can't because they're different. So you get a linker error. Yeah. So I mentioned that if in every single file I needed to use the add5 function, if I just put in the prototype manually, it's prone to errors because of this kind of thing. And depending on the error, it can be a little bit of a hassle to track it down. So the better way of doing things is to create a header file and put all of your prototypes in the header file. Then whenever you need that function or those functions, you just pound include it. And what does pound include do? It just puts a copy of that file right there where the pound include statement is. So you end up with all your prototypes right there. Goes through the compiler. Now the compiler's happy. Everything's named the same with the same case, so the linker's happy. Is this making some sense? Any questions on that? Okay. So that was that song and dance. Let's see, right quit. So I'll leave those there. All right. This is where we left off last time. We had a flex file. This is where we had some declaration kind of stuff, some preamble, some options you could provide to flex. If you have anything bracketed, and just like the preprocessor looks for things that begin with a pound sign, flex looks for things that begin with a % sign. So this is lines 1 and 3 are telling flex that what's going to follow is some code that you should just blindly paste in there. Okay? Remember, flex generates C code. Then we have a set of rules that are in the form, let me do that a set of rules that are in the form pattern and then action. So what I'm doing is I'm putting some code here in curly braces. You generally only need the curly braces if you have more than one statement. Just out of habit, rather than deciding whether or not to put the curly braces, just put curly braces around everything. You'll be fine. And then this is, down at the bottom here is user code, which is literally blindly just pasted at the bottom of the file that Flex generates. If you're invoking some fancy function here, some fancy functions here, then you might put the definition for some fancy functions down here. Okay. I said let's run it through Flex. We noted that it generates this C file. Again, Flex is the new improved version of Lex. That's why this is called Lex and not Flex. Also, we talked about the double Y's. To prevent name clashes, they paste the double Y everywhere. And then I tried compiling it. Let's see. And what kind of error did I get in reference to this? So now we come full circle. What kind of error is that? A linker error. It got through the compiler fine. So key, how can we tell apart other errors from linker errors? Your main clue, there are a couple clues. Undefined reference almost invariably is referring to a linker error. Also, like redefined or redefinition, that's also a linker error. You also tend to see this kind of stuff. Yeah. Actually, this is actually quite informative. Yeah. So it's trying to operate on object files. And notice it's in /temp. So remember I was doing all those options, and we had the -s file and the .s file, the .o file. There's no magic that keeps those from being created. When you just say G++, 1.cpp, 2.cpp, and so forth, it still generates all those files, but it has to put them somewhere, so it puts them in /temp, links them all together, and then it deletes all that stuff from /temp. So all that stuff actually does get created when you're compiling, all the object files that are then linked together separately. Okay. And so that's what's happened here, is it comes up with some random name, shoves it in /temp, the linker's trying to link things together, and it can't find certain things. So we saw this error before when it couldn't find add5, because add5 wasn't in the code we were compiling. So this is saying that there are a couple errors here. Undefined reference to main, so there's no main function. And there's no reference to YY-wrap, which is presumably some other function that is used. Let's look at YY-wrap first. There's an option that you can provide on the compiler, and this is true in both C and C++, which is -L. -L means library. Now we see the word library. Remember I had harping on not calling the pound include, including a library, because that's not what you're doing. A library, what a library is it is those .o files. Now traditionally, if you go way back, they still exist and they're still a thing. Well, let's see, we can actually probably, if I cd into user lib, let's do an ls here. Yeah, this is getting fun. And there's nothing there. All right, let me go out a little bit. We can find something. Let's see if I can. So this is in the user lib directory. These are SO files, which means they're shared libraries. I don't want to talk about the distinction yet. There should be, in fact, I'm just going to have to look for them specifically. There we go. It's these ones that end in the .a. The A means archive, but for intents and purposes, they're libraries. So I can look inside of some of them. Let's see what's inside of these libraries. If I say, there should be, I'm going to look at this one, libm right here. So I will say AR-T, which is examine the titles inside this archive, where archive is synonymous with library. And what is that archive full of? .o files, which means at some point in time, someone compiled all of these C or C++ files into object files and lumped them all together into this archive/library. Okay. So this, when I want to have the link, let me see what I want to say. It is the linker that uses the object files to link them all together into an executable, all right? So coming back here, I can say gcc or g++ lex.yy.c. There is a library called FL, which is just short for flex, and that will grab object files for functions that had been written previously for flex that we then link to, right? Does that make sense? Someone wrote a function for flex, compiled it a long time ago, put it in this library, we can link to it. Let me give you an example you may very well have run across. Anyone use that function or anything like it? Anyone power functions? How about that at pound include? Does that pound include look familiar? That ever get used? All right, you have to take some exponent, square root, anything like that. You have to use these math functions. And there are a couple things you had to do. One is you had to include math.h. Why did you have to do that? Because that contained the function prototypes to all these mathematical functions. There was one other thing you had to do, which was, let me actually try compiling that. Okay, it's complaining. Let me include math.h. I wonder if this thing is going to, it did, this G++ complain. Okay, so this is something that you're not having to do anymore. Well, where I wanted to go with it was that all of the math functions are in the math library. In fact, if I go back to here, what I did is I looked at, let me look at the command I did. Oops. I looked at the titles for the math library. That's what the M represents. And so all of these object files, you can see that trigonometric functions, square root functions, right? All the source code was compiled and dumped into this math library. In the past, you'd get a linker error. It looks like it's now linking in the math library, so you don't have to do it manually. But in no. So that's never cross paths between include and library. You're never pound including a library. All you're including with pound include are the prototypes for all those functions. The little one line, this returns a double, it's called POW, and it takes two arguments, a double and a double. Right? That's all the pound include is. You're never pound including a library. The library is being brought in by the linker. And so it looks like here, that's a good question. The G++, what G++ is doing is it's actually running that workflow. So G++ runs the preprocessor, and then it runs the compiler, then it runs the assembler, and then it runs the linker. And at each of those stages, it's providing some additional information. When it runs the linker, there are actually about 10 things that it puts on that line. So even if you're doing hello world, there are about 10 things, and all those are like the bootstrap code so that you're able to run it from the command prompt. So that's what's happening there, and that's why it's happening, is at some point in the not too distant past, maybe it's been a decade, I don't know, they have added that math library to that linker line.
So does it know about to link the math library based on the include standard or based on your using the PAL function? And how does it detect
that's a good question. So the bootstrap stuff that allows you to run it from a command prompt is in there automatically. I don't know whether it's adding the math library automatically or whether they're finding it in the compiler and then passing that information down the workflow. I don't know which it is. I find either equally plausible. Another thing to note is that if you do not use the function, it does not add that .o to your executable. So we see that this math library here has dozens of object files. It is only going to actually add the object file to your executable if you call the function that is in that object file.
So it must just detect it.
Well, so that's separate, right? That's assuming that I have the math library on my linker line.
Okay.
All right. And so all this, what I'm calling a static library, this archive, all this is a convenience mechanism. Rather than me having to compile something and then having to do user lib, slow exp avx.o, right? And I list out 4 or 5 or 6 of these for the 4 or 5 or 6 math functions I'm calling. All I have to do is say -lm, and the linker's smart enough to pop open that archive and examine every object file to find those that have the source to functions that I'm invoking. All right. So all of that song and dance then was, getting back to here, was I had said gcc g++ lex.yy.c, undefined reference to yyRap. yyRap is in the Flex library, which contains a bunch of object files of functions that were written and compiled some time ago. We note that our linker error has gone down. Now we just have one linker error. Let's look at, so I can go into here. Oops. Once I add main, then I get rid of the last of my linker errors. So it's complaining about yyRap and main. I added main myself. yyRap was in that library. I had the linker look in that library. Now it finds everything just fine. There is another way. Let me say this. One thing, let me make one note, is that if you're running on a Mac, the version of Flex it's running is a bit different, so your mileage will vary a little bit. If I come up here, there's actually an option. Remember, this is for kind of declarations and options and so forth up here. There's an option, no yyRap. I think that option creates kind of a dummy definition of that file so that you don't have to link that library in at the end. So with this, I should be able to get away with not having the -l option. Mac users, try this. And in fact, I can try that here. Nope, didn't like that. Oh, yeah. Oh, thanks. That gets to the next thing I wanted to talk about. So this is a problem that you'll run into is we have two separate steps. You have to run it through Flex to generate that code. Then you have to compile that code. Right? I made the classic mistake, which is never invade a country in Southeast Asia. The other one, I don't remember the exact quote. It's somewhere along those lines. The other one is don't forget to run Flex before you compile. Here I did the error of trying to compile and I didn't run Flex. So the way to do this is in your workflow, don't try to remember it every time. Oops. No, let me just do this. See, now that I got the order right, it was fine. What I would do is a little trick, which is Flex first to, and I actually in the assignment write-up, I say don't forget to do this. So I actually have it written in the assignment. So this is taking advantage, let me comment that out. This is taking advantage of short circuit logic. And so let me ask about who knows about short circuit logic. Assume this is C or C++ code. So what this if statement will do is it'll check if the variable a is equal to 5 and we call my func and it returned 23, then I'm going to do something. Okay, what is short circuit logic saying about this expression? That's right, meaning that both the left and right hand side of that expression need to be true to do the then part of the if. If you check a equals 5 and that's false, there's no reason to check any further, right? You know the whole expression is going to be false. So there's no reason to do this stuff to the right of the and. My func will not be called if a is not equal to 5. So that's what I'm doing. Let me clear. Here, whoops, not there. Here is I'm calling Flex to generate code. And if there's any problem with your Flex file, it will not try to compile. So it'll only try to compile if it ran Flex successfully. So this is a nice bit of short circuit logic that you can use to keep from making the mistake I just did, which is compiling and having forgotten to call Flex. Because inevitably I would have spent the next 15 minutes in that Flex file scratching my head not knowing why it's not compiling. Okay? So that's that. Any questions? Oh, I guess we should look at it. Let's see what we did here. This is pattern action. So what pattern is it looking for? Any single character. Yes, that's what the dot is. And the action is to say, I found one. Let me create a test file. Let me actually just bring it up in an editor. I'll call it test input. All right, test input is on the right. On the left here, we will try running it. In the current directory, I want to run a.out, and I want to pass into it test input. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. What are the blank lines? They're the new lines. Now, are they the white? Is it the new line or the white space? Let me come back over here and let me put it in a space here. So it's only new lines, right? And in fact, if you look at, I believe it's in that PDF that I gave you as one possibility for regular expression reference. If you look at the dot, it actually says any single character except new line. Okay, so that's why you're seeing that. Let's trick it up a little bit. Let's add a new line. And I'm just going to borrow this code. Let me expand that. And we'll say it rather glumly in lowercase. New line. Now I have to, let me see, I can come back here. Let me quit out of this. So I'll do that. Now I can run. And there are my two new lines. What about, let's look at this test input. What if I want to do something special if I find 2, 3? Let's come here. Let me borrow that. Oops, where's my 2, 3? So that's the 1. That's our 2, 3. That's 4, 5, new line, 6, 7, 8, 9. The space is in there somewhere, the last new line.
How does this handle order
Why did it choose line 10 instead of line 8? If it matches more than one of these, it is the one that is longer. Yeah, if the pattern, whichever matched pattern is longer. If they're the exact same size, then it's going to be the order that you've got them listed here. Okay? All right. So let me look back at this assignment now. That's 111. Okay, that was kind of the regular expression stuff we did in class last time. You're given an input file. You're going to write a scanner, if you will, which is what that file with the -L extension is. Or at least that's a flex source that generates C code that once you compile the C code, that compiled program is your scanner, as far as getting the terms exactly right. What I want you to do is really the pattern size of this is pretty pattern side of this is pretty simple. These are the patterns I want you to look for, and if you find a match, so for instance, if you find a match to the word quick, I want you to just see out adjective. No new line, just adjectives, right? So it would be similar to this, except I'd go ahead and go straight to the semicolon and not have the end line there. Each of these. And then I've got, here's that. I've got a question to ponder down there. And all I'm asking you to do, and then you can test it with this input file. So get it running, test it, and then there's an assignment submission where you can submit it. Right now, the due date is Sunday night. I think I want to keep that, given all that we've talked about today and really the lack of complexity to the patterns you have to come up with. I think it's well within reach that you can do this. Of course, you can. I encourage you to post questions to Piazza if you have them. The reason, so part of the motivation for why I'm having you do this is that your scanner, as we move forward, is going to identify tokens, and it's those tokens that Bison is then going to process. Okay, and so I'm trying to simulate that whole idea of the tokens through this activity here. All right. Any questions? Then if we had a bunch of time, I'd say, go ahead and get started on that now. We're nearly at the end of class, so we'll just break class here and go forth and be productive.